think the hardest part is just trying to build that f of x plus h correctly. So again, all you're doing is you're taking away the x's, and then in place of the x, you're going to put in a parentheses x plus h. So I just want to see if you can, if you're able to do that. Should finish that. Every x gets replaced with x plus h. Yeah, every x gets replaced with x plus h. So let me kind of start us off here. So here's f of x. Okay. Go ahead and remove all the x's. And whenever you remove an x, go ahead and put a blank space, a reserved blank space for that x. So now guess what we can put in all these empty spaces? X plus h. Yeah. Okay, does that make sense? So I think the parentheses help, especially if you're having trouble deciding where does that x plus h go. There's just going to go in for all the spots where the x was. All right, so now you're just replacing the numerator with these expressions that you can work on the limit for. And your goal is to get rid of all that function notation, that f of, so that you can actually work with the problem. Because right now, that function notation prevents us from being able to do much. If it helps, let me highlight what we're going to replace. This piece gets replaced with this, right? Because they're the same, right? And then the f of x gets replaced with the original expression. Now, I think it's really helpful if you put a set of parentheses in around the f of x, because that negative can present a problem if we forget to distribute. So as a reminder, to distribute, we'll put a parentheses around f of x. Okay, so now it becomes a limit problem. H is your variable. Direct substitution, we should be able to confirm that this will give us 0 over 0. So 0, and for h, I get 2x squared minus 3x plus 1 minus 3x squared plus 3x minus 1. All that cancels out. We know there's a hole, and we know there's an h hiding in the numerator. So we're going to have to find that h so we can cancel out and then reevaluate. We know x plus h is same thing, x plus h squared is same thing as x plus h times x plus h. So we got to make sure we FOIL. Continue cleaning up. Okay. Take out a bunch of like terms. And the remaining terms, we should be able to factor an h out of the remaining terms. And h goes away, just like what we want and expect. Now, what's the final step? For what? H, good. H is the variable here, not x. And the hint is over here. It says h approaching 0. So you know that h is the one that's moving. H is the variable. So replace your h with 0. And what are we left with? 4x minus 3. So 4x minus 3 is our slope for 2x squared minus 3x plus 1. And the reason why that variable is there is because we know that a curve has an ever-changing slope. So this parabola, whatever this parabola looks like, we have this describing the ever-changing slope on that curve. So we say f prime of x. This is a custom-built derivative slope formula specifically for this 2x squared minus 3x plus 1. That's what we achieved. Any questions there? Okay, number 2, it says use the alternate definition to find f prime of 2. Then we still need to look at number 1. So with alternate definition, this is going to take us directly to the slope value. And the first thing that we do is we do something with the c's. What do we do with the c's? Replace them with what? Not x. We're trying to find what f prime of 2. Yep. So replace all the c's with 2's first, and then things will begin to help us see the next step. Again, just like general definition, we're trying to find a replacement for our function notation in the numerator. So what can I replace f of x with? That's the original function. And what can I replace f of 2 with? Or what is f of 2 asking us to do? The y value, right? What's f of 2? 0, right? F of 2 is just root 2 minus 2, which is 0. So the alternate definition, the difference here is that this will take us directly to a slope, a number. Meanwhile, the general definition takes us to a formula. And if we want to find the slope, we got to take an additional step by plugging in that number. But this will take us directly to a numeric value, which is our slope for this curve at that point. I can drop the zero, right? It doesn't really impact anything. Okay, first step, direct substitution, right? What do we get? Zero over zero. So we know there's a hole. Now, typically we do the conjugate method, but here there's only one term here. I mean, well, there was a minus zero, but we just dropped it. So if there's only one term, you only have to multiply top and bottom by the radical. So there is no conjugate. I mean, you could do root 2 minus x plus 0, but that's just the zeros can just drop out. So in this case, where there's no term that's being added, you just multiply by the radical, and that will get rid of the radical. Okay, the top expands out to just be what? What happens when I multiply two radicals together? Just 2 minus x. And as soon as our radical disappears from the top, we know that we're trying to find a pair of factors to cancel out because we know that we're expecting a hole, right? Because we're getting that 0 by 0. That tells us that there's a common factor. So do you see a common factor? It's not exactly the same. So what can we do to make a match? Like factor out a what? -1, yeah. So once the factor goes away, then what's our final step? Oh, yeah. Sorry, that's not a great example. Let's see. Oh, sorry, I changed it on my key because this was a wrong point. But this ends up giving us undefined because this is an endpoint, and the endpoint, the slope is never going to exist at an endpoint. So that's why this ends up giving us -1 over 0. But that's typically, if you see a problem like this, it won't be at a strange point where you can't find the slope. So, but that's a process, right? The process is, even though this didn't quite work out, that's because I didn't I should either change this to a different point or change this to a different point so that it doesn't land at a bad number, because this ends up giving us an endpoint. And slope never exists at an endpoint. But the process is the same. Well, if I had given you better numbers, it would have given us a real number, and that number would describe the steepness of the curve at that point. Okay, let's go back to general definition. So first thing you want to do is you want to build out your f of x plus h and start by having a set of reserved parentheses where the x was, and see if you can get the x plus h in the right spots. Okay, let me check your process, because this will be a similar setup as number 1, just now there's radicals involved. Just rewriting. Just what are you doing? And they're going to 37 for things. That is, yeah. So. Fine, so now you have this piece, and then you have to put it all into this. You have that piece minus what? That's right, yeah. And then we're going to get a comment. Good. Then put the representation in the right substitution. You get 0 to 0, and then go make your conjugate. Yeah, we cancel the 2 out, but that's one same thing. We can call that abundance. So this is going to extend all the way out because that minus 1 is inside, so minus 1 is staying inside. Yep. And then what's the conjugate? Yeah, with a plus in between. Now we have to finish out the definition that you've created at best, let's say, which is that piece. They still got it right now. So you got it. So you're just putting it into this addition. You have that piece, we still need to subtract that. What was that plus?
Oh,
Yeah, that's right. So this should be what our derivative looks like when we plug in x plus h. Fx plus h minus f of x. So this is what it looks like after the numerators have been replaced. So now this should feel like a normal limit problem, direct substitution, conjugate. I think the challenge for us is, can we get to this point? Do we know how to build that f of x plus h? Because f of x is easy, right? F of x, you're just copying the exact function. It's the f of x plus h that students get kind of tripped up on. Once we confirm 0 over 0, we can multiply by the conjugate. If you're done with 3, try to go to number 4. We gotta be careful with the when we multiply this portion of the conjugate out. The two, if we multiply two radicals, they go away, but the minus sign is going to end up distributing through. So we do want to put that in a set of parentheses as a reminder that the negative distributes through. And once that negative distributes through, a bunch of terms will cancel out. All the h's will pair up nicely. There's a 2 left over at the top. And then the bottom, replace the remaining h with 0. We're left with root 2x minus 1 plus root 2x minus 1. These are like terms. So 1 square root plus 1 square root equals 2 square root. So what we've achieved is we found a slope formula, a derivative function for the original curve. So any location that I give it, it'll give me that number. That number tells me how steep the original curve is at that point. Okay, page 6. And then we're ready. Does anybody still need to look at number 3? Right, first things first, we want to find a suitable replacement for f of x plus h, because we already know what f of x is. Give you a starting point so that you know where to put that x plus h. Distribution 0. Probably not. So that you have f plus h. You got to put everything into this notation here. This is your problem we're working on. So this gets plugged in here. Minus 1. Yeah, that's right. So just imagine rewriting this whole thing, and just you're replacing these with these two. So it's the right complex fraction. Good. Now what I'm gonna do is copy this notation in front as well. But this looks right. All that looks right. Just have to put that notation. You have to copy it down here. But first you have to confirm 0 to 0, right? Okay, good. Okay, so you have this piece. Yeah. So finish off the rest of it. Yeah, minus. 2. Okay, we're just applying the limit definition. We just want to get that numerator replaced. We're essentially working on this problem, but we need the numerator to not be in terms of f of x. We need, or our function notation, we want to get it to something that we can actually plug in and actually work with. So this should be our starting point now with our limit problem. Any questions with this setup? Okay, first things first, we plug in 0. 0 will give us 2 minus 5, 2 over 5 minus x minus 2 over 5 minus x. That's going to be 0 over 0. And we know there's a hole. There's a h that's hiding in this upper portion. So we got to do common denominator. So I'm going to step to the side and do common denominator and go through that process. So I'm going to work on this problem before I return. Okay. What's my common denominator for these two fractions? Are these the same? They're not the same, right? So these are completely separate, even though there are parts of them that are the same. So how can I find a common denominator if I have two distinctly different ones? I need to include what? I need to include both of them, right? So my common denominator is both 5 minus x minus h and 5 minus x. It needs to be large enough where both of them can multiply into the common denominator individually. So what is this fraction missing compared to this updated common denominator fraction? It's missing a 5 minus x. So I need to multiply the top by 5 minus x. And this one is missing, yeah. So now we're going to clean all this up. So 10 minus 2x. I'm going to distribute the negative 2 through the set of parentheses. Tens cancel out. 2x's cancel out. But remember, we're doing this as a separate part, right? All this is just to clean up this top portion. Now we got to take all this and put it back into our problem. Okay, so we're making progress because we're able to combine two separate fractions down to one fraction. And now dividing by h is the same thing as multiplying by what? Multiplying by the reciprocal, right? H just cancel out, just like what we wanted. We knew that we got a 0 over 0. We knew that there was a hole. We found that hiding h up in the numerator. Now what's our final step? Yeah, yeah, plug in what? 0 and 4 H, yeah. Sorry, this is X here, not H. So my F prime is 2 over 5 minus X squared. So this is going to do the job of describing how this original function is behaving in its slope. Now there's a second part to this problem. It says find what? Find F prime of 3. So it's asking, what is the slope of the original graph at 3? And now that we have a slope formula, we can just plug in and find the steepness of that original curve at this point. Two over 4 is 1/2. So at 3, the curve is going to experience a steepness of 1/2. Okay, any questions? Number 5, it says use either the general or the alternate definition. I think we have enough space to do both. So on one side, we'll do the general definition, see if we can find the derivative function, plug in -1 to get the slope, and then do point slope form. And then the alternate side, we should be able to get the same thing, except it'll take you directly to the slope. Okay, let's do the general definition first. Set up your function so that you can know where to put the x plus h in your function. If you run out of space, you can always pick out, I think some of the problems on page 4 we didn't do, so you can use the body of page 4 if you want. I think there should be enough space for us. Let's do the general definition first. X plus h. Make sure you don't forget about your f prime limit, h approaching zero notation, and also the fact that we're dividing by h. I know most of our work is trying to get that numerator set up, but the rest of it is still part of our problem, right? And part of our notation. Everybody okay with initial setup here? We get 0 over 0 if we do direct substitution. And now we're just trying to get all that numerator cleaned up so that we can cancel out a bunch of like terms and factor an h out so we can cancel it out. So just be careful with this middle portion that you have to make sure you FOIL out your x plus h. You can't distribute through, right? You gotta expand out your x plus h, get that expanded out, then distribute the 3 through. And then we always want to protect our f of x with a set of parentheses. Otherwise, that negative may not get distributed through. So I'll make sure we distribute that negative through. So we should always be able to factor an h out of our remaining terms. Once our h gets factored out, we can take those out, replace the remaining h's with 0, and then our f prime ends up being 2 minus 6x. So this is going to tell us how the slope is going to look like at every single point on the original function. So to write the equation of tangent line, we need order pair and slope. Order pair, we can plug -1 into the original function to get the order pair. Here I'm showing how to find the slope. If I replace every x with -1 in my f prime, I get positive 8. So that means this graph is going to experience a slope of positive 8 on the curve. So if I plug -1 back into the original function, I'll get a y value of -5. So -2 minus 3 is -5. So I have my order pair, I have my slope, and this is my point slope form. This is the equation of the line that's going to skim the surface of the curve at their shared point, -1, -5, and it's going to also have a shared slope, y equals 8. So the line is going to skim the surface of the graph with the same steepness of the graph at that point. We should get the same results with the alternate definition. So the alternate definition will take us directly to this slope of 8. It should take us directly to this number. It's going to bypass the derivative function and take us directly to 8. So remember your alternate definition. The first thing you do is replace every c with the x value that you're given. So rewrite your alternate definition, replace every c with -1. And now, again, you're just trying to find a replacement for your numerator of your definition. I can replace f of x with what? Yeah, 2x minus 3x squared. And I can replace f of -1 with that's just the y value of the function, right? Which will be -5. Yeah. So once I have that, then it's just a limit problem. Direct substitution, you'll get 0 over 0. Factor, clean up, and we should be able to work our way down to so 2x minus 3x squared plus 5. If I factor a -1 out, I get a trinomial factoring I can do with this problem. Multiplies to be -15. That's my a times c. Adds it to be -2. Coefficient of 3. So it's going to be -5 and 3. -5 times 3 is -15. -5 plus 3 is -2. We get factored form of 3x minus 5 and x plus 1. X plus 1 cleans out nicely, meaning that the whole has been removed. We reevaluate our limits. We get -3 minus 5, which is -8. -8 times -1 is +8. So this matches with what we did with the general definition. General definition, though, takes us to a formula, and then we plug in -1 to get 8. This one will take us directly to that numeric slope. Okay, check your calendar for your homework. I'll send out a reminder next Wednesday that I'll check homework on Thursday. Okay, all right, come get your phones. I think after. Oh, that's there's at least. I bet you're better.